In today's lesson, we are going to be solving quadratic equations using the quadratic formula. So this is going to be a similar concept to the previous lesson where we were solving quadratic equations. However, this time we're going to be using the quadratic formula. Now this should be something that you are familiar with. You would have learned the quadratic formula in grade 10. We did look at it in some of our review lessons, and you may have covered this concept using the quadratic formula. Whether you knew it as solving the quadratic equation or just using the quadratic formula, it is essentially the same idea. So what we want to do right now, do you remember the quadratic formula? So if you do not, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And these values we get from the quadratic and standard form, ax squared plus bx plus c. So again, remember our quadratic has to be in standard form in order for us to find these values and use the quadratic formula. So we're just going to use a quick example. We want to use the quadratic formula to find the x-intercepts. Now, one thing to note, similar to when we're factoring, it has to be set equal to 0. So in some cases, maybe we have to rearrange our equation to set it equal to 0, or just make sure that everything is on one side so that we can set it equal to 0. So we have our a, our b, and our c value from this quadratic. I'm going to plug that into my formula. So negative b, or negative 7, plus or minus the square root of 7 squared minus 4 times 2 times negative 4. All divided by 2 times a, or 2 times 2. X is equal to negative 7 plus or minus the square root of 49 plus 32. So in this case, I included the negative with the 4 at the beginning here. And when I multiplied it through, and then just took whatever my answer was and then added or subtracted it to the 49, depending on what the sign was. In this case, it was a positive, so it was plus 32. Divided by 4. Take this a step further now. X is equal to negative 7 plus or minus the square root of 81 divided by 4. And this is now, I'm going to split my quadratic into two parts. X is equal to negative 7 plus the square root of 81, or plus 9, divided by 4. And I have x is equal to negative 7 minus 9 divided by 4, minus the square root of 81. And then simplified, I get 1/2 and negative 4. So that means for this equation, or for this quadratic, my two x-intercepts are 1/2 and negative 4. Now with the quadratic formula, you may have learned about the discriminant. If not, that's okay. It is a portion of the quadratic formula. So it is involved. You would have seen this before, you just may not have known the term. So thinking about quadratics, thinking about parabolas, do all parabolas have two x-intercepts? The one we just did, or the one we just looked at did, it had two x-intercepts, we had two answers. Are all parabolas like that? In this case, the answer is no. Even if we're just thinking about how we can draw it, right? Opening up, opening down, different ways it can touch the x-axis, so maybe it's right on the x-axis, maybe it's above or below, right? Just from there, we can kind of see there's different solutions. And there are actually three scenarios. And the three scenarios are we either have 0, 1, or 2 solutions, or x-intercepts. So there are three possible scenarios that we could come across. And the discriminant is a portion of the quadratic formula Specifically, it's the portion or the value under the square root. So the b squared minus 4ac part of the quadratic formula. And this portion or this value will tell us how many solutions there are. So if we're only concerned about the number of solutions, we can use this discriminant to tell us what or how many x-intercepts there are, or solutions. And the three different scenarios, because we have 0, 1, or 2, if the discriminant, is positive or greater than 0. So that means if b squared minus 4ac is greater than 0 or positive, we have 2 x-intercepts. If b squared minus 4ac, or if the discriminant is equal to 0, we have 1 x-intercept. And if the discriminant is less than 0 or negative, there are 0 x-intercepts. So 3 different scenarios, 3 different possible values or ranges of values for our discriminants, and that will tell us how many solutions we have. Again, it won't tell us what the solutions are, but it will tell us how many. So it depends on what the question's asking or what we're concerned about. So let's just take a look. We're going to take a look at solving a quadratic with a different number of roots. We're going to look at the different scenarios. The one thing that's going to be different, because you might say, well, we've just done that. We've done that in grade 10. The difference is now we're going to look for the exact answers. And the exact answers are expressed as a radical or a fraction. So these are solutions, or these are answers where we don't turn it into a decimal. So we're going to use our knowledge of radicals that we've learned previously and use that to help us get exact answers. So we want to find the exact solutions for 3x squared minus 10x plus 5 equals 0. Okay, so we want to find out what are the x-intercepts for this quadratic. So we're going to take our values, our a, our b, and our c, and we're going to plug it into our quadratic formula. So x is equal to negative b, or negative 10, which is just positive 10. 10 plus or minus the square root of negative 10 squared minus 4 times 3 times 5, all divided by 2 times 3. So this becomes 10 plus or minus the square root. Everything underneath the discriminant works out to be 40. So right now, just by looking at the discriminant, the discriminant tells me that we have, or it's a positive discriminant, so that means there should be 2 solutions divided by 6. Again, it's not telling me what they are, but it is telling me that I have 2. The next thing we can do, after we know whether we want to find the discriminant or not, doesn't really matter. We're finding the exact answers anyways. We can actually simplify the radical. So the square root of 40 does not work out to a nice number, but we can simplify our radical to 10 plus or minus the square root of 4 times the square root of 10. So we're using our knowledge from before of radicals. This is all going to be divided by 6. Bring this up. I can simplify it a bit further. X is equal to 10 plus or minus the square root of 4 is just 2. 2 root 10 divided by 6. Here, we can actually common factor the numerator. I can take a common factor of 2 out. So 10, or not 10, 5 plus or minus the square root of 10 divided by 6. And I can simplify a little bit by canceling out the factor. So I have 5 plus or minus square root 10 divided by 3. Because if I'm multiplying by 2 and dividing by 6, that's the same thing as I can just say I can divide by 3 instead. It's the same idea. And then now I have my two solutions. X is equal to 5 minus root 10 divided by 3, and x is equal to 5 plus root 10 divided by 3. Those are my two solutions. And they are the exact value because they're not as decimals. Let's go through and do the same thing. The next one, same idea. We have our a value, our b value, and our c value. We're going to plug that into the quadratic formula. So negative b, or negative 8, plus or minus the square root of b squared, or 8 squared, minus 4 times a, or negative 2, times c, which is negative 5, all divided by 2 times a, or 2 times negative 2. X is equal to negative b plus or minus. If I simplify in this root, I get 24. So again, I see it's positive. I'm going to have two solutions. I can simplify that radical. So x is equal to negative 8 plus or minus root 4 times root 6 divided by negative 4. X is equal to negative 8 plus or minus 2 root 6 divided by negative 4. I can take a factor out, so x is equal to, we'll take a factor of 2 out, so 2 negative 4 plus or minus root 6 divided by negative 4. I can cancel out some roots, or just cancel out the factors. X is equal to, x is equal to negative 4 plus or minus root 6 divided by negative 2. You can actually cancel out the two negatives as well. So x is equal to 4 plus or minus root 6 divided by 2. And then now I'm going to have my two solutions. X is equal to 4 plus root 6 divided by 2, and x is equal to 4 minus root 6 divided by 2. Again, order doesn't really matter in this case. I know in the last one I put the negative on top. Doesn't really matter. We have our two solutions. Now the next scenario we're going to look at, so we looked at two roots, we're going to look at one root. One thing to note, if the quadratic only has one solution, then the x-intercept is also the vertex. Right? So if it has one x-intercept, it has to also be the vertex. And again, nothing's really going to change in what we're doing. It just means we're just going to only have one answer in the end. So we have our a, our b, and our c value. We're going to take those, plug it into our quadratic formula. X is equal to negative 24 plus or minus the square root of 24 squared minus 4 times 36, all divided by 2 times 4. X is equal to negative 24 plus or minus. Everything under the discriminant works out, or under the root works out to 0. We can divide by 8, 2 times 4. And we get x is equal to negative 24. Right? Now, when we take the square root of 0, it's 0. It doesn't really matter. Right? So we don't really add or subtract anything. So this one actually works out nicely because we just get x is equal to negative 24 divided by 8. If it helps, if you want, you could say plus or minus 0. But again, that does nothing. Right? It's not going to change anything. And we get x is equal to negative 3. So that is our one solution because of this 0 discriminant here. Now, one thing you could also do if you don't like these large numbers, you could common factor at the beginning and take a 4 out. We would have x squared plus 6x plus 8, or no, not 8, plus 9 equals 0. And then you could look at a, b, c in that factored form. So you could common factor as well. It would still give you the same answer if you went through and you did x equals -6 plus or minus the square root of 6 squared minus 4 times 1 times 9 divided by 2 times 1. You would still get the same answer in the end of x is equal to -3. So either way you choose to do it, if you like working with smaller numbers, you could look at common factor first. In this case, you'll still get the same answer when you use the quadratic formula. Solving quadratics with 0 roots. So there are two scenarios where we could have 0 roots. Right? This could be something where it's above the x-axis, or the vertex is above and it opens up, or it is below the x-axis and it opens down. Right? So both are possible for our quadratics. Again, from the equation, we might not know. Right? So what we can do is we can still go through and take a look, A, B, and C. So x is equal to -b, or -11, which is +11. So 11 plus or minus the square root of -11 squared minus 4 times 8 times 5, all divided by 2 times 8. X is equal to 11 plus or minus the square root of 121 minus 160 divided by 16. And when we go and simplify a little bit further, 11 plus or minus the square root of -39 divided by 16. Right, so this value here, the discriminant, is a negative value, and we can't square root a negative. So we cannot square root -39, so therefore there are no solutions. So that's what we're talking about. With the negative number, we can't square root it, so there are no solutions to this quadratic. So that just means there are no x-intercepts. So it's one of the two scenarios that we kind of mentioned above. Now again, with the discriminant, right, maybe we don't want, we don't care what the solutions are. We just want to know how many roots does it have. We just want to know the general shape. Right, so the discriminant still uses the a, the b, and the c, but it's only the portion underneath the square root. So that's the b squared minus 4ac. So that's the formula that we're just going to use, and we're just going to check to see what the value is. Is it positive, negative, or 0? So 5 squared minus 4 times 2 times -5. We get 25 minus 4 times 2 times -5, or 25 plus 40 equals 60. So therefore, 2 solutions, because the discriminant is positive. So that means when we were doing the quadratic formula, it'd be the square root of 60, and we would add or subtract that to our values. For b, again, a, b, and c in our quadratic formula, our standard form, we got -7 squared, -7 squared minus 4 times 3 times 5. So we have 49 minus 60. Doesn't really matter what the answer is. I can already tell it's going to be negative. But for argument's sake, let's go through. We get negative 11. So therefore, no solutions because of the negative discriminant. We wouldn't be able to take the square root of that negative 11, so we wouldn't be able to finish our quadratic formula. And then lastly, again, A, B, C. You might be able to guess which one this one might turn out to be. 12 squared minus 4 times negative 4 times negative 9. We get 144 minus 4 times 4, negative 4 times negative 9. Ooh, minus 144 equals 0. So because the discriminant is 0, therefore there is one solution. So again, this is just looking at the discriminant, and this is just if we want to know how many solutions there are. Again, it's not going to tell us what they are, it's just going to tell us how many there are. One application question. So a ball is thrown, and the equation below models its path. So we have h at d equals negative 0.25 d squared plus 2d plus 1.5, where h is the height in meters above the ground and d is the horizontal distance in meters from the person who threw the ball. So for A, we want to know what height or at what height is the ball thrown from. So in this case, the height where the ball is thrown from, this means that there is no horizontal distance. So this is where h at d equals, or not h at d, this is just where d equals 0. So in other words, this question is saying, well, h at 0 is what? What is the height at a horizontal distance of 0? Well, negative 0.25 times 0 squared plus 2 times 0 plus 1.5. H at 0 is equal to 1.5. Oops. So that just means, therefore, the ball is thrown from a height of 1.5 meters. D asks, how far has the ball traveled horizontally when it lands on the ground? So if it's landing on the ground, this is the key portion of what we're looking at. Right? Or that's the key information. Because if I were to look at a graph of this parabola, right, it starts at 1.5, it's thrown, and it goes and hits the ground. Right? We have our height, we have our horizontal distance. Right? We are essentially looking for the x-intercept. So when we're talking about it hitting the ground, we're looking for an x-intercept. This is where the quadratic formula will come into play. So here we have our equation, right, where we can set it equal to 0. 0 equals negative 0.25 d squared plus 2d plus 1.5. This one actually works out nicely because I can common factor out this decimal. So I can common factor out a negative 0.25. I end up with d squared plus, or not plus, minus 8d minus 6, because I common factored out that decimal, so my numbers are getting a little bit larger. Now I can take the values of my standard form, so this, plug it into my quadratic equation. Let me just kind of move things around just to make it a little bit neater, a little more organized. So essentially, d, or x, is equal to negative b, or negative 8. So we have a, b, and c. Now keep in mind a is with that imaginary 1 in front of the d value. So we have negative 8 or negative b, so 8 plus or minus the square root of negative 8 squared minus 4 times a, which is 1, times c, which is negative 6, divided by 2 times a, or 2 times 1. I get d is equal to 8 plus or minus the square root of 64 minus, or not minus, because negative, or plus 24 divided by 2. I get d is equal to 8 plus or minus the square root of 88 divided by 2. And now it's not asking us for the exact value, so I don't have to worry about converting my radicals or simplifying my radicals. I can just work with the decimal version. So I would do d is equal to 8 plus root 88 divided by 2, and d is equal to, let me keep it consistent with what I've done so far. And d is equal to 8 minus root 88 divided by 2. I get two possible answers. One I get as 8.7. 8.7 meters. The other I get as negative 0.7 meters. So looking at this, which one would we take? I have two answers, but which one is correct? Well, if we take a look at it, right, if we're talking about how far the ball traveled horizontally, can we have a negative horizontal distance? In theory, no, we can't throw a ball and it goes a negative distance, right? Unless we're throwing it backwards, but it would still technically, I guess, have a distance, unless we're looking at a distance time graph, so to speak. So that means that this negative value, right, this value here does not work. Right? So that negative 0.7, actually, let me just put that over here. So this value does not work. Doesn't mean it's not an x-intercept. It just means for this scenario or in this context, it does not work. So this means that therefore it traveled 8.7 meters. So in some cases, we might need to use the quadratic equation to find the x-intercepts for how far something flew or how far it landed. Right? But the idea is just being comfortable using the quadratic formula to determine the different number of solutions for our quadratic, as well also understanding what the discriminant is and how we can use that to help us determine the number of solutions.